Eventually it'll come up.
There we are.
There we
Now
go. All right, cool.
We're live.
We're live.
So I'm trying to think. I don't think anything really stuck out like as super confusing. I don't know. Did you have any questions or anything you wanted to go over, or?
No, I mean this chapter seemed a bit more complex than the previous ones, but I felt like I understood it. So
Yeah, the whole what is it 65-95 or 68-95-97
yeah,
thing?
I gotta remember that. 68, 95, 99.7.
99.7. There you go. Yeah. One thing I'm finding is that as they teach one thing, I'll get down the formula to how, the equation, and then when they add another one, it's like, okay, now I got to keep track of this one too. So I keep looking back. That's how it is, right? Yeah. Especially with all these different signs and stuff that I haven't really used before, like that crazy U and those other things, sigma or whatever.
Oh yeah, the sigma and the I just call them U's and O's.
Yeah. Yeah.
One question I did have, and I was looking through the reading, and maybe I just missed it, but on the QQ plots, so basically that's just like the plot of the Z indexes for all of the data, right?
Yes.
And so basically the way that we figure out, if it's normal or not is just looking at the shape of it.
Yep. From my understanding, if it's a relatively, straight line, then it's normal. If it starts off going straight and then curves kind of like an arch, then it's not. And then I even think if there's some little dots that are outliers, then it's abnormal as well. So from what I understand, I think as, the straighter, the more normal it is. So
yeah. That's what it just seemed like. I was just curious, like, where the lines were as far as determining if it is normal or not.
Right.
It kind of just seems like it's kind of objective to be like, well, look at the graph and see what
if it looks straight. Yeah. I mean, judging off of the what was it, that preparation thing, the answer key, all of the normal ones were just, pretty straight. And so I don't know, that's all I have to go off of.
Yeah. So I mean, it makes sense. I just was curious
if there's something like a more technical, more exact way of knowing or something.
Because I guess there is, because they have like the you can look at the Z value for the particular item, I guess, to see it. Well, that's just for a particular data point, but because they said that if the Z index or the Z value is greater than 2 or less than -2, then it's considered outside the range of the normal data.
Right.
I mean, I guess technically you could probably even use that type of approach if you just looked at, the data in general and thought, okay, these points that are outliers, how far away are they? You could kind of use that approach at least. But I was just curious. It seems a little objective, but
yeah,
that's kind of the point, I think. So,
have you done the homework by chance?
I haven't yet.
Okay, because there was a question, I got it right, but the way that I went, because I don't know how to explain it. So I did it the way that we were told to in one of those videos, and I got one answer, and then I did it another way, and I saw that the answer was an option, and I went for it, and I got it right, but it didn't. I don't know. I was confused as to how to find the right answer the right way. But
okay.
So maybe next week.
Yeah, maybe next week. Bring that up, and we can talk about it.
Yeah.
On Tuesday, after we've done the homework, we can see what's going on.
Okay.
Cool. All right.
Want to do the quiz?
Sure, let's do it.
Okay, let me pull
You
them up.
probably need to bring up that applet, huh?
What? Oh, right, yeah. Let's see.
Oops. No, I'll just do that. $18 questions.
Let's see. Oh, okay, we're on lesson 5, right?
Yep.
Okay. One sec. Okay, so number 3, it says the total area under a density curve is equal to 1, right? I think that's what the video said.
Yeah, that's what I put.
Under certain circumstances, a density curve can drop below the axis. False.
False. Yep.
A normal density curve is symmetric. I think so, right?
Yep. True. Let's see. I'll go ahead and read since we can alternate.
Okay.
Use the following image to answer questions 6 and 7. Which of the following elements of the figure represents the z-score in this image? I believe that's C, correct?
Yeah. Mm-hmm.
Okay. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1?
Is it B?
Yeah, that would be B.
8 says, according to the 68, 95, 97 point, or 99.7 rule, what proportion of the data from a bell-shaped distribution will be within one standard deviation of the mean? It's 68%, right?
Yeah, yep.
Okay, so far so good.
Yeah.
And then suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from the random variable will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. Okay, wait, so what's the sign?
Wait, what? I'm confused.
I don't, if I understand it right, we don't even need the applet for that. It's just the whole 68% thing, right? Because it's saying what proportion of the values from this random variable will be between -1 and 1? Isn't that, is -1 and 1 referring to the standard deviation? Or is that, or what is it? I don't know what it's saying.
Yeah, that would be, because that's the z-score. I mean, the z-score is how many deviations it is away. So what portion of the values of this random variable?
But what random variable?
Well, so if we put it in the applet, then it says that the area is 0.6827.
Oh, so it wants it, they just want us to give it in 3 decimals. So it's 6, 8, what? 27?
27, so yeah, 683, I guess.
683, yeah. Okay.
That sound right? Suppose
Yeah.
random variable z has a standard. Okay.
And then suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from the random variable will be between -2 and 2? So
Let's see, 0.955.
So are you doing, are you putting a 0 in front of yours, or just 0.995 or 9, wait, what was it, 995?
Yeah, 0.955, sorry.
Oh, 955. So you're doing a 0 in front?
Yeah.
Okay, I'll do that too.
That's what I put in.
Okay.
It's just that directly. Well, sorry, 0.955. I rounded to 3.
Okay. And then the same thing for -3 and 3. 0.99 or 997 or something.
0.997. Yeah, is consistent.
Okay. And then look carefully at your answers to the last 3 questions. What do you observe? Okay. The values match the rule, right?
Yep.
Okay.
All right. I think that was the point, so that should be good.
Yeah.
Sweet. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.66 gram Pascal, yeah, whatever that unit is.
Yeah.
And the population standard deviation is 0.07. Use the information to answer questions 14 through 17. What portion of the population have a protein requirement that is less than 0.6?
Okay. So
Answer 3 decimal places.
So for this one, are we going to be doing that equation where it's are we wanting to find what x is or the z-score?
Oh yeah, we want to find the z-score with 0.60.
Okay, so it's 0.60 minus the population average, right?
So 0.66 divided by the deviation, which is 0.07. Let me bring up my calculator.
Yeah, I don't have mine on me. Let's see.
All right, here we go.
One sec, I'm gonna go grab my calculator.
Okay.
Maybe do you want to do that right now?
Yeah.
Hey.
Hey guys.
Hey, stranger. How's it going?
Crazy.
Where you at?
I just got to school from work. From
okay.
my kid's school, yeah. So.
Hello.
Sweet. We were just going through the quiz.
Okay.
Are you on a laptop or are you on your phone?
I'm out of school. Yeah, I'm just on my phone. Sorry.
Oh, okay. No, that's cool. I just was curious if you were wanting to start taking the quiz now or you'll just do it some other time or something.
Okay, for that one, did you get negative 0.857 for the z-score?
Yep, that's what I got.
Okay, let's see. Negative
Okay.
0.857.
Okay, so for Jason, what we're doing is basically the next few questions are based on the fact it's about proteins, and it says that the mean protein requirement for adults is 0.66, and then some weird units. So the mean is 0.66, and that the standard deviation is 0.07. And so we're using those values to figure out the z. Right now it's saying what portion of the population have a protein requirement that is less than 0.6. And so that's what we're figuring out.
Now, I guess my question is, when it says, what is it, proportion or something like that? That's asking for the z-score. Is that what that's referring to, or the percentage that's getting that amount of protein?
Probably the percentage. So we're probably wanting the area
Okay.
that is less than that value. So
we got to put that in the applet?
yeah. If you want, I can. Yeah, you should probably open up the output and do it too.
Yeah. I gotta get that real quick.
Let's see, but for Jason's sake. So I believe, so what I did was just put in that z-index, and then since we're saying what portion of the population what is less than 0.6, so since the z-score is here, we set the z-score to be there, and we want the area under the curve that's less than it, correct?
Yes.
That should be...
Okay. I finally pulled it up. Okay, so we want less than negative 0.857.
Yeah.
And I got 1957.
Yep, that's what I got too.
And how many decimal points do they want this at?
It says to 3 places.
So 196? Or do they want it like 19.57%?
It says give your answer as a decimal.
Oh, okay, so
Yeah,
0.196.
basically exactly what's in the area, just rounded.
Okay, 0.196. Cool. Okay, so are we ready for 14?
So what portion of the population have a protein requirement that is more than 0.6? So we should be able to use the same values. We're just going to look at, instead of doing less, we want the entire curve that's above that z-score. Correct?
Yeah, 0.804, I think.
Yep, that's what I got. Sweet.
Okay. What proportion of the population have a protein requirement that is less than 0.70? Okay, so we got to do the math for this one.
Yeah, so we should be able to just do the same thing as the first one, just with different numbers. So
Yeah.
0.7 minus 0.66.
I got 0.571.
Yep, that's what I got too.
And we want to know what percentage is less than that. I got 0.716.
Oops. I hit the wrong button. Wait, what'd you get?
0.716?
Oh, right. Good job.
Okay.
Yeah, that's what I got too. The first time I didn't include the middle value. That would be correct because it's not negative.
Sweet. Okay. Oh, you know what? I remembered my question that I was trying to explain. So on the homework there was a question. It was similar to this, but you see your graph or the applet thing. So it wanted to know what the area is of the middle, and in one of the videos it said you can simply do the right side minus the left side, and that'll give you the middle. And I think it was at like standard deviation 1 or 2, or I think it was at like 1, and I did that, and it was coming out to 0 because, you know, it's the same on each side. But I got the answer because it was one of those 68, 95, 97 rule things, because it was at the first standard deviation. But doing it the the other way, it didn't come out with the right answer. So
The other way, as in like,
where you, because in the video it said to find the middle, the area of the middle, you do the area to the right on the right side minus the area of the far left side. And that right. So if you click the right side, yeah, and then if you subtract the left, then it'll give you the middle. I don't know.
oh, so you took these two and so.
And since it's the same, it just comes out to 0. So it's like, I don't know. There's,
Huh.
yeah.
Yeah.
And I must have misunderstood the thing, because that just doesn't make any sense, I guess.
Yeah. Maybe when we'll talk about it next time. Maybe I'll go
Okay.
get it wrong. Or right.
Yeah.
Hopefully I get it right.
Hopefully right, yeah.
Yeah. We'll see.
Okay.
Okay. So number 16. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Hint, remember to find the area between two values, shade the left of each z-score you calculate, and then subtract the smaller area from the larger area.
That's the thing.
That's what I was wondering.
This is it.
Yeah.
This is the type, yeah.
So I was wondering about that because, like in the video, I think and in the textbook, it explained this. Really, the reason for doing that, from what I understood, is because our applet isn't super flexible.
Right.
I mean, if we could move the z indexes independent, then we wouldn't have to do that.
Yep. But since they're different z-scores, it doesn't work.
Yeah. So if we just go and basically, since we know this area, and then if we move this and take this area, then we could figure out what that area was.
Wait, do that again. I wasn't looking at the screen.
Oh, sorry. So if so say that, well, let me just do what we have here. So our first z index was negative 0.857, right? And then it was asking, so it's asking for everything that is between 0.6 and 0.7. And so that basically means we want the area in the middle, right, between those two z-scores.
Right.
And so everything that is, let's see. So yeah, we'll start here. So everything that's less than that value is this area, right? That was the first number we got. And then if we put in our other z-score, which is 0.571, it moved the values, right? And so since both of these are moved, we have to subtract. Well, now we've got too much stuff on this side, right?
Yeah.
So we need to subtract out what we want, what's greater than 6 and less than 7, if that makes sense. And so since we know the old area, which was 0.196, we can subtract that from 0.716 to get the area in the middle, because this line is no longer in the right spot. Does that make sense?
Right. You know what? That's what I did wrong. I was doing the far right side minus the far left when it should be, you know, the middle and left minus the left.
Yeah.
If that makes sense. So that's why I was
compensate for removing what is extra from the other side, if that makes sense.
Yeah. Okay. Hey, well, I got my question answered. That works.
Sweet. Yeah, I wondered that too as I was like reading it, and then I was like, oh, that makes sense, because we're just trying to remove the extra.
There we go. So what did that one come out to?
Let's see. So what we're gonna do with that is take 0.716 and subtract 0.196, and I get 0.52.
Yep.
Right?
Yeah.
And probably want to do 0.520.
Because it's to 3 decimals.
Yeah.
Okay.
Sweet. Okay, cool.
I'm just going back and putting the 0 before the point because the instructions have that and I've been forgetting to do that.
Oh, okay.
Maybe I don't want it to be like that comma rule, you know?
Yeah, yeah. Yeah.
Okay, so now we're on 17. So find the 35th percentile for the protein requirement for adults. Okay. For this one, is it the x equals the u plus then z times sigma or whatever? Is that the?
Trying to remember.
Yeah, I remember doing this, but I can't remember how to start it.
Let's duplicate that.
I think it is because the x equals the value, you know, and I think the value is going to be the 35th percentile.
Yeah. So yeah, we take the z index equals x minus the mean over the deviation. Is that what you're talking about?
Actually, I was thinking of the other equation, x equals the mean plus z index. Oh no, maybe that. Yeah, I think you're probably right.
It's the same one, just with the x moved around.
Right. So which one do you think it'd be? The one where it starts with x or where it's the z index one?
It should be the same. The one that I said just hasn't solved for x yet.
Okay.
And I think I think we're talking about the same equation.
Yeah, right. But it's just configured differently.
Yeah.
Okay.
So that would be, what is it? Let's see. X. Where is that? Let's see. So x would equal the z index times the deviation plus the mean, right? Is that what you're saying?
Right.
Okay. Yeah. That's the same equation, just moved around.
So for this equation, what do we got? We got where does it say the mean and standard deviation again? So the mean was 0.66 and the standard deviation is 0.07. So we don't have the z-score, do we? Or was it negative 0.857? We had that from.
Yeah. So x, let's see here. Yeah, so x is the, oh, maybe not. Oh, right, the area. So we're going to put in as the area what the percentile is, right? So 0.35.
Oh, that's how you do it, huh?
Does that make sense?
Yeah, that's right. Let's see where 0.35. Yeah, so it's z-score negative 0.385, right?
Yep.
Yeah, I forgot that's all you have to do. Put in the applet. And then so 80th percentile, same thing, 0.85.
That's what we're putting. It says find the 35th percentile for the protein. So we're just putting in the z-score?
I think so.
Okay. Is it, let's see, would we do the negative or?
I think it's the negative because a percentile means like 35th means that you are greater than or I think equal to 35%. Like, okay, if there's 100 people and you're the 35th,
Uh-huh.
higher than
35 of them.
right. If that makes sense.
Uh-huh.
So I think it'd be the left one because that's. I think so, right?
Yeah. So then on the next one, we want to include the middle area as well. When
Yeah.
we do the area.
So I guess it'd be the right side of 1.036.
Find the 35th percentile for the protein. Yeah, I'm just curious, like, what is this? So he wants, I don't know, I'm confused if he wants a z-index.
What do you mean? If that we write,
Says, and maybe that's, well, I guess that's a good question. Because it says find the 35th percentile for the protein requirement for adults. So when we say find the 35th percentile, what does that mean? I mean, just give me the z-index for that percentile? Or like, I guess that's the only thing that makes sense.
yeah, I think it is. I think I remember some problems where that's all they did. They just plugged in, the percentile. I think, but I mean, I'll feel bad if we get it wrong. But
No, I think that's right.
okay, so you have negative.
Let's see. Here's it says calculating percentiles as a normal distribution. Percentile is the number such that specified % of the data are at or below that number. Okay. So to find the z-score corresponding to the 90th percentile, click on the regions of the graph so that the area to the left of one of the bars is shaded and nothing is shaded to the right. Then type the number 0.9 into the box at the top of the applet and press enter. So yeah, I guess if we put in, if we put in our 0.35 in here, yeah, it automatically is going to ignore the lower because it's below 50%.
Right. So that one I'm pretty sure is right.
So it says the value is that, and so then it says, so that gives us the z value, and then it says, so z equals this, and the z that corresponds to the 90th percentile of a normal distribution. Okay, and then it talks about how to find the batting average that corresponds to the 90th percentile.
Yeah.
So we can solve for x for the equation. Oh, so yeah, we don't want to just give the z-index. We want to then use the equation we use that z-index to find out what the actual value is.
Oh, good call. Okay.
That makes sense?
Yeah.
I was like, that doesn't really make sense to say find the first 35th percentile and then just give a z-index.
Yeah, right. Okay. So we do use that x equation, right?
Yeah, so that's where we actually use the equation that we just talked about.
Okay. So
that's where we're going to take. So for 17, we take negative 0.385, and we'd multiply that by the mean, which was 0.66. And then we would add we'd multiply by the deviation, sorry.
Yeah, 0.07, right?
Uh-huh. And then we add the mean.
Yeah.
Sweet. All right, that makes a lot more sense.
Yeah, it does. Yeah.
I was confusing myself.
Let's see.
Let's see if we do 0.385 times.
I got 0.573.
Let's see here. Maybe I did that wrong. I don't like this calculator. I'm getting a different calculator. Let's see here. So negative 0.385 times 0.07 plus 0.66.
You know what? I just kind of.
I got 0.66 or 0.63. That you got?
I did it again and I got that 0.62695, right? Yeah, so 0.63.
Well, I got 0.63305.
Oh, geez. Okay, I didn't get that. Okay, so my equation I wrote down is 0.60 for the mean plus, and then in parentheses, negative 0.3.
Wait. No, the mean is 0.66.
Oh, it's 0.66.
Uh-huh.
That's why. Okay.
Yeah, we're not using the 0.6 and 0.7 anymore.
Okay. But is the standard deviation 0.07? Is that right?
Yeah, that's correct.
Okay, so let me do that again real quick. Okay, I got 0.63305.
Yep.
And we just do it.
I assume that we're rounding the same as we did on the other ones.
Yeah, so just 0.633.
Yeah. I hope. Or does he want it just like we'd had the values where it's only 2?
Well, everything else it's saying round to 3 decimal places, right?
Yeah. I'm cool with leaving it at that.
Okay. And then for the 80th percentile, I actually erased the z-score. Do you know what that one was?
Yeah, I just did 2. 0.842.
I got 0.718, so or it would be 0.720. No, never mind. 0.719.
Yes.
Zero. Okay, 0.719.
9. Sweet. All right, we're good?
Yeah. Let's see. I think we're good. So Jason, he got disconnected, or what happened?
Oh, I don't know where he went. I wasn't paying attention.
He was there for a minute, then he disappeared.
Yeah.
All right, are you ready to submit it?
Yeah, I'm good.
Okay, let's see. Got 100. Nice.
Sweet. Very nice. Cool.
Yeah, we got saved there. We would have gotten like a B or something if we would have kept those last 2 questions.
Yeah. Cool.
Awesome.
Sweet. Well, thanks, Michael.
Yeah. See you Tuesday.
Yeah, good talking with you. Let me know if you're gonna switch to computer science now.
I know, right? Okay, I'll look into that. I'll let you know.
I have a tendency of talking people into it, so don't let me sway you unfairly.
Have you had some people switch over to it because you've talked to them, or?
I don't know if I'd take credit for it, but I've talked to them and they've switched. So.
Yeah. It sounds pretty interesting. So.
Yeah. The other nice thing is that currently the job ratio is 3-to-1, as in for every graduate there are 3 job openings.
Oh, nice, man.
And
wow.
They anticipate that within the next 5 years to be like 8 or 10-to-1.
Oh, geez.
So yeah.
What was I about? Oh, is that something you would want to get a master's in, or just stick with the bachelor's, or how do people?
Yeah, that's a really interesting question, because like they really the only reason you'd want a master's in computer science is probably if you're going to teach, like at a university level.
Okay.
if you do get a master's and you go into industry, you know, actually going and writing code for a company, really all that would buy you is that you're going to be doing the exact same things as somebody with a bachelor's degree. You'll just get paid more at the beginning to do it. But the interesting thing is that for most engineers, the tendency is that so imagine you get a bachelor's degree and you go start working, then you'll be getting paid about the same amount within, 2 years of the amount of time it would have taken to get a master's as those who went and got a master's and then started working.
And then starting off higher. Yeah, so it's kind of not really worth it, I guess. And because you're paying for the master's and you're not making much money during that time, so.
Yeah, for most, most people don't get masters in computer science unless, like I say, they're going to go teach. What is helpful, though, a lot of people, they'll get a bachelor's in computer science and then an MBA, so a master's in, like, business administration. If you want to, go and do, basically, if you do that, then you can go and get a job as a manager, right off the bat. And so if you want to be more in, the management side instead of the technical side of the business, then that's usually what people will do is they'll go and they'll work as a developer and then they'll go get their MBA, maybe even while they're working. There's quite a few companies that will actually pay for you to get your master's as well. So you may not be paying you could go get a job with your bachelor's and then that company might pay for you to go and get your master's degree.
That's nice.
Yeah. So that's typically, if you're going to go get a master's, that's what people will do is usually they'll go get an MBA or a master's in some other field. Because that's the interesting thing is with computer science, it's about computers, but you work in geology, you work in, health sciences, you work in all types of these different fields because you're developing software for those applications. And so you have to know things about those as well. I don't know, I like to compare it kind of to being like a lawyer because lawyers have to know a lot of things about a lot of different things.
Right.
And so that's kind of what, as you're working on a project, you get to learn a lot about geology and you get to learn a lot about, these different application domains that you're actually working on. And so some people, they'll go and they'll be like, I really like working in this particular area and I love doing computer science with it. So I'm going to get a computer science bachelor's degree and then go get a master's in geology. And then I'm going to work in that field. And so if you do get a master's, people usually don't get it in computer science unless they're really wanting to go into research in computer science. But it's very common for people, if they do get a master's, to go get it in some other field, especially business administration.
Are you thinking about doing that or probably just sticking with
For now, I'm just going to get a bachelor's and then go work for a little bit. I have thought about getting an MBA, and I might still do that, but I'm not really in a hurry to right now. So
right.
It happens.
Be nice to make some money.
Yeah.
After college,
Yeah, and just in case you're wondering, so typical salary for an engineer, it really does depend, but it's usually between 50 and 80,000 is generally what engineers get paid out of college, and then that usually increases.
Good. Nice. That sounds good to me.
Yeah. Anyway.
Cool.
So there's some information.
All right, man. Yeah, thanks a lot. Have a good one.
Yeah. See you, Michael.
Yeah.